Okay, in this video, we are going to talk about reference angles and terminal points. So a reference angle is, you want to think about the distance to the closest x-axis. So if you're in quadrant 1, you're going to go down here. If you're in quadrant 2, you're going to go down here. 3, you go up here. And 4, you go here to the positive x-axis. So you're just trying to get to the closest x-axis. Any reference angle then is going to be between 0 and 90 degrees, or between 0 and pi over 2 radians. And then terminal points, that is going to be where your angle, the terminal side of your angle, intersects the unit circle. So right there on the unit circle, whatever that ordered pair is, that is your terminal point. The x-coordinate on the unit circle is cosine of theta, and the y-coordinate is sine theta. But that's still just distance out and up in the xy plane. Okay, so let's look at these two angles. Let's start with theta equals 420 degrees. What we're going to do is find the reference angle and then use that to talk about the terminal point. So 420 degrees, that would be a full rotation, 360 plus some more. So if you subtract 360 from 420, you get 60. So 420 is actually equal to 360 plus 60. That puts us right up here, and this is our angle theta. And now you can see sort of in this setup, this is your reference angle, but if you don't trust that, look at your picture. This distance right here is 60 degrees. That is your reference angle. So the sine and cosine values here, that terminal point is, let me label this, our terminal point. Think about this triangle. There's a lot going on in that picture now. Let's see. Let me draw the triangle separately. So if you have this triangle, this triangle is really tall, but not very wide. So this is going to be 1/2 and root 3 over 2 and 1 on the unit circle. That would make this ordered pair 1/2 root 3 over 2. That is the cosine value, and that is the sine value. And the point is that you can go back up here and say, well, the sine of theta, or the sine of 420 degrees, is equal to plus or minus the sine of 60 degrees. Since we're in quadrant 1 and sine's positive there, you would pick off the positive one, and the sine of 60 is, of course, root 3 over 2. Okay, so let's move over to the other one now. We're looking at 7 pi over 6. So that would be 6 pi over 6 plus some. So we would be in quadrant 3. This is 6 pi over 6 plus pi over 6. And again, this is your reference angle. It is the distance to the closest x-axis. This distance right here is pi over 6, or 30 degrees. Okay, and then the terminal point, you want to look at where this angle intersects the unit circle. And I'll draw another picture triangle out here so we can see that a little bit better. You've got this triangle that is really wide but not very tall. So those numbers are going to swap. This would be root 3 over 2, and this would be 1/2. This is 1. But we're moving left in the xy plane, so that x value is negative, and down, so the y value is negative. In quadrant 3, both the x and y values are negative. So you have negative root 3 over 2 and negative 1/2. Your terminal point, that's it. The x value is negative root 3 over 2. The y value is negative 1/2. This is the cosine of theta, and this is the sine of theta. So using that same sort of argument we were talking about just a minute ago, the sine of 7 pi over 6 is equal to plus or minus the sine of pi over 6. In this case, we would pick off the negative because we are in quadrant 3, and that's how you use reference angles to figure out unit circle sine and cosine values. Let me know if you have any questions.